we have got time for a few questions now, or whether we want to leave that till the next session, end of the session.
When can we access MitoPads?
So we're starting to onboard people on the 6th of August in Newcastle. That will probably be a small core to begin with, work out the teething problems, and we would anticipate that in a few months after that, we will start onboarding more and more people.
Just adults?
No, it can be parents of children. We've very much encouraged Mitopad to think about how we will do this for kids. The first phase will be adults, but we will be looking at carers and parents, because some of the patients won't be able to use the phone app, so we want some of the adult patients won't be able to use the phone app, and we want their carers to complete it. So I think the same would be true for the paediatric population as well. Okay, we have got time for some further questions later on, so I'll not...
Okay, great. Thank you very much, Bobby. Oh, you are. Sorry, I was just about to...
So I'll take that applause, that's fine. So you don't escape that easily. It's 5 to 3, so we can fly through. This is the Mito cocktail, which you're all very familiar with the Mito cocktail, I'm sure. It doesn't look like this, unfortunately, but there may be a few of these going later on. Okay, so I touched a little bit on this last time, but how do we know if a medicine actually works? Well, what we do is we do a clinical trial in humans with robust, relevant outcome measures. Okay? Well, that's really that end of this spectrum, which takes about 10 years. Lots of this is preclinical research, so it doesn't go anywhere near a patient. Someone has an idea, they develop it, they try it in mice, they try it in a small number of patients, and then we get the large-scale clinical trials, and the cost is about $2.5 billion to get to that stage. That's how we know if a drug works. There's a lot of fallout on the way here, so many of the bright ideas at this end don't end up being developed into drugs. And even some of those drugs that are developed don't work. There's lots of legislation around what constitutes a drug. The Human Medicines Legislation Act in 2012 for the UK. It's overseen in the UK by the Medicines Healthcare Products Regulatory Authority, often abbreviated to the MHRA. Doctors are the only people allowed to prescribe medicines, and they're only allowed to prescribe medicines that have a license. Food supplements, vitamins, are exempt from that licensing process, and they're covered by food law, which in my house was banning the kids from the fridge. That was the food law. But in fact, if a food makes a claim, so a manufacturer of a food supplement makes a claim that it is of medical benefit, then that does come under the regulatory authority of the MHRA. And some herbal medicines can be sold if they have a traditional herbal registration with the MHRA. So that's just a little bit of background. If any of you have insomnia tonight, I can provide you with this detailed report from the food supplements from the Department of Health. And you'll see why I've given you this sort of background in a moment. Essentially, clinical trials, as I've suggested, are very expensive ways of figuring out whether a drug works. Manufacturing vitamins is dirt cheap, costs pennies. Vitamins are generally safe drugs. They're safe at the standard doses anyway. and some of them you can give 10 times the dose that they're prescribed at and still cause no problems. There's no patent on vitamins, but some compounds, combinations of vitamins, have got a trademark. Okay, so they are licensed, they're trademarked, I should say, by a particular company as the proportions of vitamins in that is their intellectual property. An example of that would be this MitoGuard Intensive made by BioCare, £28.50 for 14 sachets. I'm not selling them. They've gone up actually for the last year. I showed that slide last year. They're only £27.95 last year. But you can see that with no patent, cheap manufacturing, and the expense of running clinical trials, that it isn't an attractive proposition for companies to actually buy license for vitamins or compounds to run clinical trials, especially if the outcome of that clinical trial is going to be that it's of no benefit. So that puts us in a bit of a pickle, and you will see actually that BioCare were very clear to market that as a food supplement. So what can we do in mitochondrial disease? Well, there are all sorts of potential openings for treatment. One of them is scavenging excess reactive oxygen species, antioxidants, increasing the amount of mitochondrial DNA building blocks that are available. I'll talk a little bit about that later on this afternoon. Or promoting the growth of more mitochondria. Do any of the vitamins that we currently use in the vitamin cocktail have any role in any of these processes? Well, ubiquinone may well do, but nobody's ever been able to run a large randomized, double-blind, placebo-controlled trial of ubiquinone. So this looks like a very scary, complicated diagram. It's not particularly. This is the mitochondrial membrane. This is the inner membrane. This one's involuted here. This is the outer membrane. This is the machinery that allows ATP, this energy currency of the cell, to be made. Don't need to know too much about the details of that. Ubiquinone is an electron carrier in the mitochondrial respiratory chain. I've highlighted it here with a red arrow. This is CoQ10 sitting in this machinery. We don't think that's where the CoQ10 that we give, though, actually ends up. I think it probably ends up here and knocks up some of these electrons that make this toxic stuff and act as an antioxidant. So these are superoxides here. They can cause damage to proteins in and around the cell. And we don't like too much of that. A little bit's good, but not too much. And so ubiquinone mops up some of those electrons, we think. We offer ubiquinone to everyone in Newcastle, and I think that's generally the case throughout the highly specialised service in the UK. We offer it for a 3-month trial at 100 milligrams once a day. Some of our adult patients have reported back improvements in fatigue and a little bit in muscle ache, which seems to be more of a problem in some of the later onset mitochondrial DNA diseases. But I've got to say, we've not had fantastic results. I'm sure I'm speaking for everyone here that ubiquinone isn't a wonder drug on it, and those of you who've used it would probably say the same. But it is remarkably safe. It's not particularly cheap, but even if it's having a small benefit, I think it's worth prescribing. So if after 3 months someone says, yep, I'm sure it's done me good, we will continue to prescribe that. If they don't or can't articulate clear benefit, then we'll stop, but continue to review. And if people feel that actually coming off it, there's been a step down or a deterioration, then we'll offer to restart. Okay. As I say, it's very safe at high doses. 5 minutes left, right? My goodness. Okay, so riboflavin, vitamin B2. It's a water-soluble vitamin. It's found in nuts, meats, eggs, dairy, green leafy veg, all the stuff that's good for you. But the body doesn't hold on to it for very long, and it excretes it fairly readily, and we actually have a fairly limited capacity for absorbing it from the gut. So it is important that it is in our diet every day. It is important in the, I'm sorry this has gone off the edge, but it is important in the generation of two important molecules in this mitochondrial respiratory chain called flavin mononucleotide and flavin adenine dinucleotide, FAD and FMN. And they sit in complex 1 and complex 2. It seems to be of benefit in ACAD9 mutations, so a very specific form of mitochondrial disease which causes complex 1 deficiency. There have been some reports of benefit for people who have those genetic mutations on taking riboflavin. As a matter of course, we tend to give riboflavin to patients with identified complex 1 deficiency from their muscle biopsy who are awaiting genetic confirmation of their mitochondrial disease. Thiamine, another B vitamin made in bacteria, fungi and yeast. It's found in cereals, meats and nuts. Our adult colleagues adult clinical colleagues often see thiamine deficiency in patients